Now let's look at 16.2, sample space diagram. So when do we use a sample space diagram? We normally use something called a sample space diagram when we are calculating outcomes of two different events that happens together. So the simple ones that we can do is, for example, throwing a dice, throwing a six-sided die and flipping a coin. These two events has different amount of equally likely outcome. It means, for example, when I flip a coin, it is equally likely for me to get a heads or get a tails. The same thing as when I throw a six-sided die. It is equally likely that I get 1, 2, 3, 4, 5, and 6. So that's why I can use a sample space diagram to show what are the possible outcomes. So for example, when I flip a coin, the outcomes are heads or tails. When I throw a die, it would be, the outcomes are 1, 2, 3, 4, 5, and 6. Either one of these will happen. So if I want to know how many possibilities there are when I do both together, I can use a sample space diagram by writing heads here, tails here, 1, 2, 3, 4, 5, and 6. So I write the outcome of one event on this side and then another event on the bottom side. So I can see that it will happen. This is one of it, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the events that will happen will be heads, 1, 2, 3, 4, 5, 6, or tails, 1, 2, 3, 4, 5, 6. These are all the events that would happen, and then you can actually see that there are actually 12 different outcomes. All right, so you can actually use a plus. If you don't like the plus, you can use an asterisk if you want to, but normally for sample space diagram, they use a plus sign because it shows that this is intersecting with this. But this is the plus sign that actually here. Okay, so you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different outcomes. So like for example here, if I want to know what is my probability of getting heads when I spin the coin, when I flip the coin, and then getting the number 3. So you can actually see that I'm talking about this one particular event out of 12 events. So this is the probability. What if I want, for another example, I want to get a tails and odd numbers. So the events that would happen would look like tails and odd number 1, 3, 5. So it would be 3 out of 12, which is 1 out of 4. This is the answer. All right. So you can see that these are what we're talking about. So now let's look at the example given here. This is a worked example. You can see one spare spinner. So a spinner looks like this. It means that there can only be 3 different types of outcomes, and then this other spinner has 5 different types of outcome, which is 1, 2, 3, 4, 5. The other one has 1, 2, 3. So the answer is to draw a sample space diagram to show all the possible outcomes. Like I said, this is the 3 spinner. 3 sections either. 3 section spinner. So on one end, I'm going to write 1, 2, and 3. And then the bottom bit here will be my 5-sided. 1, 2, 3, 4, and 5. This will be my 5 section. Spin it. Okay, so you can see here, 3-sided and 5-sided. So the possible outcome will be here. So you will see that there are actually in total of 15 different outcomes. Okay, now work out the probability of scoring 2 2s. So let me just highlight this amount here. 2 2s. So 2 and 2. It's only 1 out of 15. 2 2s. And then the second one, 2 odd number. So both must be odd numbers. So this one is a pink color one. And then let's just say green color one for this. Odd number. How do we score odd numbers only? So 1 3 is odd number, 3 1 is also odd number. 1 3 3 3 1 5 5 5. So you have to see that there are only 1 2 3 4 5 6 out of 15, which you can simplify it to become 2/5. And then the last one is a probability of total of 5. Total of 5. So let me just highlight this as a blue color. Total of 5 will be 3 plus 2, 2 plus 3, 3 plus 2, 4 plus 1. That's it. Is there any more? No, that's it. 3/15, which is equals to 1/5. How? Divided by 3, divided by 3. So let me show you the ones before as well. Divided by 3, divided by 3. Because we simplify it. And that's how you use a sample space diagram.